Hi friends, welcome to this session on statistics for data science, machine learning and artificial intelligence. This whole statistics probability, this whole world is defined for the situation where we have uncertainty. So the whole world in itself is uncertain. Nothing is deterministic. What is happening now was unknown an instant back, and what would happen next instant is still unknown because it is controlled by so many parameters that it can't be deterministically put in some analytical form and say that what would happen at any given time t. So the whole situation is uncertain, and when we are dealing with any uncertain phenomena, then definitely the probabilistic approach will come to our aid. So in the probabilistic approach, we begin with experimenting. We do experiment multiple times and find out the outcomes. And with these outcomes of the experiments, we compute the probability of occurrence of any event. Yeah, that's easy to say. But when we want to put the things in a better way, we do need the aid of mathematics. So we do need some expressive way, expressions. Expressions means variables and symbols and many more. So let's begin defining our world. Probability space. It's a triplet that's made up of three things: 1, omega, f, and p. Omega is the sample space. That's a set of all possible outcomes of the experiment. So if we are talking of tossing a coin, then there are two outcomes possible. One, it can be head, one, it can be a tail. Yeah, that's both together, head and tail as a set is the sample space. And there are set of events that's given by f, and this must be sigma algebra. What sigma algebra we just look at shortly. And then we define p. P is the probability measure that assigns probabilities to the events in the event set. So as we said, sigma algebra is a collection of sets in omega such that if S is part of F, then its complement is also part of F. So when you're talking about some element or event of the F, then the opposite of that, that's a complement, is also part of the set. If S1, S2 belong to the set, then S1 union S2 also belongs to the set. So that way, if you sum all of them, then we get a omega. Therefore, omega is also part of the set. See, example. Yeah, we can't understand anything without example. So example is tossing a coin. Then we have two possibilities, head or tail. So both together will form the sample space and our set of events. It can be you have not yet tossed, so there can be an empty, or after tossing it may be a tail, or it may be head, or it may be head or tail. So all possible things are there. So it may be blank, that is no experiment conducted, and it is tossed, and you know the answer. The answer may be tail or head, and the coin is rolling in the air, not at drop down. So you are still not sure whether it is head or tail. So these are the four events possible. Same way, if there are three possibilities in the sample space, then F may contain a null A, B, or C, or A or C, B or C, A or B, or all three together. Yeah, that's definitions. Coming to probability, how likely each event occurs. So if you're talking about event A, then conduct some number of experiments and then find out how many times A has occurred. So the total number of times A occurred divided by total number of experiments conducted will be the probability of occurrence of A. So if we take up example, then we take a standard deck of cards. Then our aim is to find out the probability of getting an ace if you randomly pick one card out of the standard deck. So there are totally 52 cards, and there are four aces. So if you pull out any card, and if it happens to be an ace, then it is 4 by 52, that is 1 by 13 possibility is there for selecting any ace from the given standard deck of cards. Other way, you are trying to get a diamond ace only, then in the whole set of cards, there is only one card which is both diamond as well as ace. So therefore, the probability of getting a diamond ace is 1 by 52. So probability measure is a function defined over the set of F such that P of S is always positive. That means 0 and above for all symbols in F, all the events in F. If set Si and Sj belong to F such that Si and Sj are mutually exclusive, then they are called disjoint set. In that case, the probability of finding whether it is Si or Sj is the sum of two probabilities, whether it is Si or Sj. Or in short, if there are n events which are disjoint, then the probability of finding the event is either S1 or S2 or S3 or up to Sn is total summation of probability of occurrence of each individual. So that's beginning. We have many more things to come. So please keep watching this. And if you find it interesting, so please don't forget to subscribe and hit the bell icon, and do hit the like button. And please don't forget to share this information to your friends so that they can also be envisioned about these topics. Thank you.